open till submission. Yeah, not on the week, not during the week. The time of your class, right? The same regular time of your lectures and class. So all the weekend, Saturday, Sunday, from 6:30 in the morning, Canada time, till 4, right? The same schedule. Same schedule. You will have access to Moodle. You will have access to RDP on that time. Well, by the way, you are able to RDP because we had a big problem yesterday, power outage on the school that destroyed a switch or a router. And after, okay, so they fixed it. All right. We didn't have access almost all the day yesterday. Okay. Yeah, that's a nightmare, but those things happen. Okay, guys, let's go for the one. Wide area network. Wide area network. We studied other kind of networks during all the block, right? LAN, cold LAN, local area network. We saw that in this local area network, we have some devices that we use, like a switch, type of kind of routers, devices, printers, and those stuff. Okay, now those LANs are connected to each other's, depending on the distance, of course, by other kind of network called wide area network. Okay, and we talked about those ones when we studied also the topologies and the type of the network quickly, and we saw that they are really big geographically worldwide, right? One of the most biggest one is the internet, for example, and I already asked you this question on module 3. Internet is one of the most biggest wide area network that we have in the world, because it's connecting everything to everything. Okay, so what is this one and for what we use it? So they can communicate with each other's who's. See, I have an office here in San Francisco, another one in London, another one in Tokyo, another one in Houston, right? So the enterprise is really big, and we have a headquarters somewhere, maybe in New York or whatever. But you see that all the office, wherever they are, they can all connect through that wide area network. Okay, so the LAN basically can connect devices to each other's to create these small networks, and after depend on the size and how geographically we have set our network, depending the need, we can go bigger, and we need to transfer the data from one point to another point, and sometimes from one country to another country, not just a city to a city, but sometimes from one country to another country. So you can access servers from here, from Canada, in India, in Japan, in Russia, in whatever. So they are all connected through the wide area network. Those are publics, right? The web, we're just using the web. This is the internet. This is what we call the internet. But once it become a company or a private one network, it's another deal. Okay. So LAN connect nodes. LANs, they connect nodes, right? Such as workstation to server, server to printers, and other devices in a small geographical area on a single network. Okay, we can have bridges to extend those LANs, so we can connect a LAN to a LAN, but they still really close. We can use just a bridge to extend these LANs. WANs use network devices such as routers and modem to connect networks spread over a wide geographical area. Both LANs and WANs use the same protocols from layer 3. This is a really interesting sentence here in information. So they use the same protocols from what? From layer 3. Remember that OC model? What is a layer 3? Who can remind me what is a layer 3 in the OC model? A network one. Good. So from 3 and upper, the ones use exactly the same technology. From 3 and upper, the ones use exactly the same technology. So we have layer 7, 6 and 5, presentation session, application, and we have transport. And 3 is the network. Right? Is the network. We are here. And he's saying that all those layers work exactly the same way in LANs and WANs. Right? But layer 2 and layer 1, it's another story. Right? What is layer 2? What is layer 2, guys? Data link, right? Data link here. And of course, this one is physical. So we have the physical, we have the data link, that they are completely different from the LANs. It's not equal to the ones. Why that? Why? Logically, just think logically about it. Why layer 2 specifically in layer 1? Who have an idea? Just general idea. Logic. Just logic. We have our OC model, Open System Interconnect, and they are all the same from 3 to 7, almost same, right? But they are saying that 1 and 2 are completely different. Why? Why 1 and 2? Who have any logical idea? Not talking technical here, just about logic. No one. Come on, people. Try it. Try it. Try it, even if it's wrong. It's okay. Nobody. Try. You have no clue. Try it. Come on. Why the one should be different? Physical should be different. Because we are not using the same devices and the same type of wires and so go on, right? It's not the same. We're building all the kind of building. Physical is different. Here we're gonna use R232. So serial one, for the example, or so that the inputs are not the same, the ports are not the physical is not the same because we don't have a choice. We are using a complete all the technology here to transfer the data from one point to one point, all the kind of cables, all the kind of access, all the kind of everything. The frames that they should be builded on top of this physical, they're gonna be different. We don't have a choice. They're gonna have heaters that they work with this infrastructure physical one, right? But after IP address packets and forward the packets from the source to destination and those protocols and so go on, till we go to the DNS or DSCP or FTP, it's still the same, right? So we have access to FTP in the LAN, we have access to FTP on the WAN. It's the same protocol on top, right? But here, it's all because of this physical that the layer 2 also should be different. Okay? Because the frames should have other kind of protocols, other kind of logic to deal with this inferior layer physical one to be able to transport the data through it. Okay? When you transport data just with the signal network card that you have from your computer to a switch using RJ45, it's not the same that when you use a phone line to deal up in a public network switching phone call to go to the ESP, for example, right? It's not the same. Or when you use a carrier wave, okay, coming from your provider. So you use that carrier wave to be able to transport data that long distance. So it's another kind of encapsulation here. It's another kind of heaters, another kind of encapsulation. So we deal differently with these physical things till we build our frames. And of course, inside those frames, we have the same data here. We have IP addresses, and we have whatever streams or not here, connection oriented or not, and so on and so on. So we are solving basically the same problems that we have in the LAN, is to communicate to devices and they exchange data. So they communicate and exchange data through here, but here it's another technology that we are using. So the physical is completely different. We are using all the stuff, all the things that give us the ability to do that. And the data is encapsulated on top of this infrastructure that we have on the physical, is encapsulated differently also. It's not the same frames. All right. See, I told you it's not technical, it's just about logic. All right, so in which layers of the OC model the one is different from the LAN? Layer 1 and layer 2. Right? This is the answer. Okay? They are the same on from layer 3 to layer 7. So from the physical to data link, they are different. We are using other kind of frames of protocol to encapsulate the frames, of protocol to reroute those frames. But from layer 3 to layer 7 is the same. All right, so both LANs and WANs use the same protocols from layer 3 and higher of the OC model. LANs and WANs may differ in layer 1 and 2 of the OC model in access method, topology, and sometimes the media, the wires, or the way that we are transporting those data from one point to one point. LANs are mostly owned by operated by a company that use them. Okay, our LAN in Erzing, it's our property. It's our property. And when we have a problem in there, a Tao gonna bring the tools and go and check those things. He's the one who managed that network. He's the one who configured that network. He's the one who give access or not to that network. Okay, reshape it, whatever things. So it's our own property. But our LAN is connected to the WAN, is connected to the world. Okay, from that point of external router that we have in the school, it's not our property anymore. We are client to other providers. Okay, our network provider. It's Black Fiber, I guess. We are client of Black Fiber in Toronto for his. All right, so mostly owned and operated by the companies that use them. On the other hand, the ones are owned and operated by telecommunication carrier known as NSP, Network Service Provider. Network Service Provider. And of course, those network service provider, they can be really, really big to a small one. Depend on their market, depend on what they are selling. Okay. Usually they just subtrate with other smaller companies the distribution to get access to their own network. So they lease or the others pay loan to get access to the bigger network of Bell or AT&T in United States. But it doesn't mean that those small companies that you hear about them that they can give you a better price to get access to the internet or whatever. They have their own infrastructure. Not at all. They are managing other bigger provider network, so the others have less headache with it. They are the ones that they do the maintenance or any problem they will repair it or whatever. So they take care about that part. And but the infrastructure, the antenna, the whatever, the wires and so on, they belong to usually bigger company. Like here, if you take for example I don't know, all those internet ones providers that we have nowadays here in Montreal. I forget even the one that I'm using, Caritel, for example, right? There's many. I forget. I've been in different companies. They changed a lot. But it doesn't mean that they have their own network. They are all working with Bell usually, right? Or Videotron or whatever. Okay, so we have bigger companies that they have the infrastructure, and after they will just sell a part of a market to, like satellite, for example, right? It doesn't mean that when you see a channel TV broadcasting through satellite, they have their own satellite, right? So they are paying a lease of distribution of data through that satellite to another company like NASA or whatever other company, right? Telsat or okay, so those companies they build the satellite, they don't have data through it or whatever, so they sell the service of it. They can build their own channel. Like for example, if you take Bell, of course they have also their own forms and their own plans to sell the internet to people. Okay. All right. So we got a general idea about the ones. We saw that it's different on the layer 1 and layer 2 of the OSI model compared to the LAN. LAN, of course, is a much higher speed than the WAN, right? LAN is much higher speed than the WAN. We are talking about gigabyte connection, right? 100 or whatever, and small distance. Okay. So LANs are faster than WANs. LANs are also faster than WANs. They are different from the WAN in layer 1 and layer 2. Okay. The WANs are the property of the network provider, network service provider. The LANs are the property of the companies that they use them. We have a LAN here. So you see computers are all plugged to a switch, and after we have a router and poof, to the internet. So we go through this magic connection here to get access to the world. So this is our LAN here. From this router inside, this is a LAN, right? Now, a WAN, for example, is something that's gonna connect this. See, New York, how it's connected to Detroit, San Francisco, to Miami, to Austin, and so on and so on. Okay, so it's connecting bigger nodes, bigger nodes. The individual geographic location or endpoints. So this is an endpoint. This is an endpoint. This is an endpoint. And as you can see, one endpoint can have multiple connection or just one connection. So it's kind of a mesh, a partial mesh. Location or endpoint connected by a one are known as one site. So this is a one site. This is a site. This is a site, right? So those endpoints are called sites. A one link is a connection between one site or endpoint and another site or an endpoint. So this is a one connection. This is a one connection. This is a one connection, right? Wide area network connection. One link can be point to point, connect one site to only one other site. Okay, that's great. It's one point. Or multiple point, connect one site to two or more. Right. So if we take this one connection here, it can connect to three other sites after the Miami one, right? Or Miami here, you see we have three connection on it. It's not point to point. But even if we take it from here to here, this is a point to point one. But this one is not anymore a point to point. We pass through many other things, right? Don't forget, the idea behind is that we have multiple ways to go from one point to one point, right? Multiple ways. All right. So network, New York, service provider network, London, connection, point to point, or serial link, leased line. So you are leasing a cable or connection or a line between sites. You're gonna lease this line through a service provider from New York to London. That's gonna cost you a lot, right? A lot. 3 kidneys and, as I told you last time, right? 2 eyes and something like that, right? Now it's more and more replaced with the virtual private network, the VPN through a DSL or through MPLS, or we're going to talk about those things here, right? After. Because basically, this is a LAN. LAN, when we are studying the LAN today, this is, for example, building or multiple ones, right? So this is something that we study. See, to get access to this thing here. Can be cloud, can be internet, can be whatever things, right? So how we get access to this? This is the technology that we are studying. And after here also, it's another thing. How things are connected. Right? And we can even go after to a bigger thing. Backbones of the internet, for example, or another ESP service provider and so on, right? So here we have the backbones of the internet, for example, the protocol BGP is the boss here, right? Or we can go from one service provider to another one service provider here. So it's multiple connections, right? See, it's a very big spider web here. Here we're gonna have those core routers, and we go to another ESP and so on and so on, right? But this is one part that we're going to study and learn how this thing work here. And this is things that we're going to talk about here, right? That we going to talk about here. So we can pass through the internet, we can pass through all the thing also. More private things. Or we can use the internet and encode everything, right? Remember that virtual private network, when we use a VPN, we can have anonymity and data integrity and security and authentication and so go on. So encryption and those stuff that we studied last time. So where the connections made across the internet. Okay. So we can pass through the internet here and we go to London, but everything is encrypted. Okay. If we don't pass through the internet, we're gonna use other kind of network. This is what we call a leased line. Well, if you can build it by yourself. If it's in the same country, for example, here from Toronto, and I'm a billionaire, like Elon Musk or whatever, and I want to have my own line, a new one, right? So I need a government, I need an authorization, I need staff, I need a lot of money, I need whatever. But usually a leased line, it's not that everybody gonna have to build it because it's already there from the providers. So we're gonna just use, for example, imagine that I have a headquarter here. Something is in MTL, and the other one is on Vancouver, and another one is on New York or something like that, right? So I can have some kind of provider that he can link just my office or blocks of the company. Or I can have even the HQ here, right? In Montreal, but in another place than this one. So this is another block of the company, right? So I can have my own network passing through my own network, and this own network, it can be, it was really famous at the time, like for example, Frame Relay network. So it's a one, but it's not the internet, it's other thing, right? Or I can pass through MPLS. That was really famous also. Okay, for a long time. Now it's more and more replaced by SD-WAN, software defined wide area network. Okay. So those technologies that they, here you will not see the people from the internet. The internet is after connected somewhere here, right? Or that goes to the world. But when my office communicate, they pass through a personal network that is provided by a service provider. And there is no internet here. I can put my cloud, my applications, my whatever, and people from the internet, they can get access to the servers that they are here, for example, for my applications and clouds. Or even my workers, they work with those applications, so they get access in the Frame Relay. That is deprecated. There's no more Frame Relay. They even removed it from the CCNA, right? MPLS or SD-WAN with VPN. So we can even put VPN here, because since it's not a really private one leased line, we're using a service. This guy, he will not just work with you, he will work with many other different companies. So it's a kind of an isolated internet here. We can use ATM, metro connection here. We have many technologies, right? Depend on the provider, depend on the price, depend on the price. So we can have that kind of leased circuit that we talked about last time. We have a pop-up from here, some routers, and we're gonna lease that circuit here. And depend on the protocol that the provider is giving. So it's kind of isolated. So you see, it's much more secure here than passing through the internet. But internet is much more cheaper here. If you pass through the internet and use a VPN, you will not pay a leased line here, right? For this kind of technology. So this is what is the difference between point-to-point, leased one, from one office to another one, or a VPN through internet or public one. Okay. So the customer's endpoint device on the one is called the data terminal equipment, DTE. The customer's endpoint device on the one is called the data terminal equipment. So we have something here We have something here. So this is the client, right? This is the client. We have something called DTE, data terminal equipment. It's the same thing here, right? So we have access through the internet, or you are just a private client that can go to the internet. We're gonna have something here called DTE. Okay. What is this DTE? The customer endpoint. The customer endpoint, where the LAN of the customer finish and we go to the one, right? So you see here, we have a LAN somewhere here, right? A LAN somewhere here, right? Our own LAN. But this is the customer endpoint. So the customer finished, the network of the customer ends on that point. This is what we call it. We call it data terminal equipment, or DTE. The carrier endpoint device for the one is called data communication equipment, DCE. Where is the data care the carrier equipment endpoint? So if the client or the customer endpoint is here, and after we go to the one, so the provider here for the one, he will have his own equipment right here, right? So to give us access to this line, right? So here we have a DCE. Okay, so DTE, DCE are one next to each others, sometimes in the same device, especially now, right? So the customer endpoint device on the one is called data terminal equipment, DTE. Here is where it ends, right? And we have another endpoint for the provider. Okay, so the carrier's endpoint device for the one is called the data communication equipment, or DCE. So they are one next to each others, or you're gonna see that it's a same device now that gonna have handle both. So primary media, see where when we use this one's technology and get access to this network. So here we are talking about this thing, right? We're talking about this line here and this fast network that we get access. So as you can see, physical and the layer 2 data link are completely different here. We're not using RG45, right? We're not using RG45 and the Ethernet cable, twisted pair, whatever. It's different. We're using copper, okay? We're using copper or fiber optic with what? With deal up over PSTN. What deprecated, right? The old way the phones, the analog phones were working, right? Well, maybe still somewhere in the world in some countries. Even here in Canada, sometimes you can find some parts, right? Parts still using those things. After we use the digital over the PSTN, the phone lines, right? Because of the lines, when we built the internet and we wanted to give access to people to that huge network, we already have connections. So people tried to use those own connections. We have phones, they were already installed and implemented at home. So we didn't want to rebuild something. The TCP IP of the internet, it's something that should be compatible and implemented on top of an infrastructure that is existing. They even tried to use the power line. See the power line? They try to pass the data through them, because we already have the lines of the powers at the time, right? They used cable modem connection. When we say cable modem connection, it's the TV cable, right? Because they started installing TVs cables to when the TV changed from that antenna, and we built neighborhoods, having this box somewhere in the neighborhood and distributing cables for the TV for people. So they said, okay, we already have those cables. Let's use them, right? The phones, let's use them. So the phone, PSTN, are we going to talk about it right after here? Public switched a telephone network. So we use a modem, and we connect to access server that he going to give us access to the ESP. And it was being improved on ESDN, so digital signal here over PSTN. When we build it digital, it doesn't mean that we changed the lines and we destroyed all the phone connection physically. No, we built it ESDN on top of PSTN. So we changed the technology, how we treat the signals, how we send the signals over it, using all the kind of devices to improve the signal and the communication to a digital one, right? And you see that this one is not encrypted. We have nothing on it. Deal up over PSTN. I have just a modem, and it's the really old way. Well, maybe you guys, you don't remember when you had that modem and you had an icon in your computer looking like a phone, right? And you double click in there and you put some phone number and you connect to the internet. And you had that piece called modem right in front of you that made that genuine sound, special sound. I remember when I was young, right? When I was connecting to the internet, and you get that. I don't know if you heard about it. This one, you're gonna make like like a water or something like that, but you're gonna hear that sound for a long time, right? You can find it in YouTube. There is no that sound anymore, but I'm pretty sure YouTube modem sound. I don't know if you hear what I hear, or otherwise you just go tape this one, the sound of dial-up internet. I was really happy when I was listening this one because usually it didn't work and the access was really, really difficult at the time, right? But when you start hearing this means the connection is going well, right? So this is the dial-up connection, right? Copper ESDN, we built the frame relay at the time here, PPP or frame relay. Frame relay is the one that's gonna go to the frame relay, right? The network of frame relay that I explained, or MPLS or whatever. Copper or fiber. When we started using T carriers, in Europe they are called E carriers, right? Different waves, different frequency, depend on dial-up connection, Bharat. Yeah, look like you are making coffee. I'm making coffee. Why I'm making coffee? No man, I'm making coffee. Why I didn't get it? Maybe I don't have any coffee. I drink my coffee this morning. Okay. So so the T carriers, or in Europe I told you, is in E carriers, different frequencies, different. So they are NSPs, those ones, right? So they are carriers. They will give you a wave. This is what we call them, carrier. We have some signal. So this is for example computers, whatever things, and we're gonna send them to a multiplexer, right? They are talking, so we have some signals with 0 1s, 0 1s here, 0 1s. We can even have a phone, right? And we have some analog signal. This is our multiplexer, but the T carrier, he have a line and he's generating already a standard wave on it, right? Standard wave. So to be able to transport those data, we're gonna put them on top of this wave. So we will reshape this wave, and after we will extract them back here. So this is what we call them carrier. It's the carrying wave, right? He's giving you this high frequency, depend on the speed that you're gonna pay for, right? We have T1, T2, T3, T4, depending the companies what they need or not. One is have better upstream, downstream, or equal ones, or different speed. So they give you this wave that can carry data, right? That can carry data from one point to one point, and you're gonna put on top of them this data by modulation. Okay, good. The DSL, we get to the DSL, different ones. We're gonna talk about them right here also, right? So VDSL, air DSL, different speed, ADSL, fiber optic. So this one use PPP, Ethernet, or ATM or Metro. Copper or fiber optic, broadband cable. This one that use the TV cables, right? And one of the most used one is fiber optic, the Sonet on layer 1. Those are really big kind of switches, routers, call them Sonet. We're going to talk about it at the end also. And those ones, they can implement many other things and compatible with the old technology. This is really important on the internet when you change something or you upgrade something or you improve something, to be sure that it's compatible with old technologies, because you are dealing with the word, you are dealing with many networks, you are dealing with a lot of things. So you can't just go and have a new technology that's gonna ask to destroy the word and build this new technology, right? No, you need portion here, portion here, portion here. But there is people, they still use T carriers. There's others that can still use ESDN over PSTN. We have ADSL somewhere. We have broadband cables. We have whatever things, right? They all have to merge together. They all have to merge together because those are belong to different NSPs, and those NSPs are all connected to each others. This is how we go from one part on the word to another part, right? They are not all in the same technology or the same standard thing or whatever. So we need something that always merge with the others, and we upgrade slowly and slowly. Like, for example, the backbones of the internet that they related Europe to United States to America continent, they were coppers once before, right? Those huge copper cables through the water passing under the ocean. Now they are all fiber optic. So we can upgrade portions, we can upgrade things, depend on the provider, what is his project and how he's doing his things. But the most important part is that all of it at the end, it can work and work together, right? So many things, they should be compatible, and this is the complexity of the of all of it. So point-to-point link. One technology differ in terms of speed, reliability, cost, distance, coverage, and security. Also, some are defined by specification at the data link layer, whereas other are defined by specification of the physical. Let's see the physical, right? So physical layer, you see that even the type of the cables, we are using totally different ones, complete different ones. It's not just this; those are just example. The V35, the X21. We have many others, right? We have many other kind of cables, but just to show you that the connection here are usually serial, and other kind of connectors and other kind of cables is not the same that we are using on a LAN local area network at all. And layer 2 here, you see that we don't have this MAC address on the frame header or whatever. Well, we still have it inside somewhere, but the protocols that we are using in there, they are completely different. See, frame relay, PPP, HDLC, ATM, MPLS, and so on, right? So we have other kind of protocols in layer 2. Layer 3, layer 4, layer 5, same. So we're dealing with the headers of IP addresses, same information that we have in there. We have LAN 1 here, for example. This is PC1, this is PC2. And we can pass through, for example, an HDLC protocol provider here. You see 800.3. This is the IEEE designation for what? For Ethernet, right? So .3 is Ethernet. So we are using Ethernet here. IP packet, Ethernet. Okay, so this is the frame. I have footer, it have header, and this is the IP packet inside. So this is our frame. We are just transporting it to this edge router of the company. And after that, we go to another kind of connection here, a WAN connection that is using another kind of headers, that is HDLC. And after we get back to the delivery to this router here, so another edge of this LAN 2 edge router, that will be back. So they will be transformed back to a LAN technology frames, right? So you see the frames here are LAN. They pass through something that we're going to talk about it here. Right? So they pass through something. They will be reshaped to be able to transport them through the WAN. Depend on the technology that we are using on WAN. We saw that there is many of them, right? And they pass through. They will figure out. They will find their way till they will get to the point of the delivery. And something happened here. They will be reshaped back to the LAN technology, so they will be able to be processed with this computer, right? So it's the same packets, but reshaped in different frames, compatible with the technology, the physical technology that we have here. It depends. We can have many, and after it goes back to the local area network here. So what is a CSU DSU? My God, look at complicated word. CSU DSU here. Sorry, it's not DCU. CSU DSU. So we have channel service unit, data service unit. The DCE or endpoint device for a leased line is a CSU DSU. That's it. You see, I told you it's not that complicated at all. It's just a word. Remember, we said that the DTE is data terminal equipment, is the endpoint of the customer, right? It's the endpoint of the customer. Now, this DCE is the DSU, CSU, more CSU DSU, more technical word for that DCE. This is what it contains, right? So, endpoint device for a leased line is a CSU DSU, which consists of a CSU channel service unit and DSU data service unit. Okay. What they do? The device can be standalone. Okay. So we can have a CSU DSU device. Okay. Or an interface card. Now it's just an interface card. Okay. I told you at the first time, so CSU DSU. There you go. See, at the time, this is how it was. I can make this picture bigger. Here we go. See, CSU DSU. So it was a standalone device, and we have a router, and all this was a DCE. Okay. So from here, we start communicating with the WAN. So RG45 to Telco Denmark. Okay. And we have that V35 between the CSU DSU and the router. Console cable to connect to the router. Ethernet, this one go to the LAN. And AC/DC adapter for the power, right? Alternative current and direct current. So this is a transformer for the power. Now, all this stuff, they are just in something like this, right? It's just a network card now. Network card, see that we have a T1. This is a T1 carrier. We have T1, T2, T3, T4. This is a network card built for a T1 carrier. CSU, DSU that we can connect right here. Okay. Interesting, we can even have a own loop back here, right? So you see, CSU, DSU. So now everything is integrated, but before it was something like this. It was separated device that we connect to the router. Now it's a integrated, and this is what we use with the carrier. When it's leased line carrier, we use a CSU, DSU. That is channel service unit, data service unit, and it's the DCE in that case of the carrier. So what these two do here, the device can be standalone or interface. The CSU, so the channel service unit, provide termination for the digital signal and ensure connection integrity through error connection and line monitoring. All right. So it's the one who start the connection, do the termination of the connection, right? And monitor the integrity of the data through an error connection. So this is the first part here. The DSU, on the other hand, so the DSU convert the T carrier frames into frames the LAN can interpret. You remember here when I told you something happened and they will be reshaped to other thing, right? And here something happened, they was being reshaped back to the normal packet Ethernet LAN packets, right? It's the job of the DSU. So here is saying that the DSU convert T carrier frames into frames the LAN can interpret and vice versa. So he do the reverse. Okay. So this one, CSU is responsible for the termination and checking, monitoring error through an error control system. All right. We have the clock in there. And the DSU is the one who reshape the packets depending the how they can go out for the one technology. And all this, where is this happening? Where this is happening? Right here, right in the front of the customer to go outside. Okay, let's imagine that this is a T carrier here, and we are using CSU DSU right here. Okay, so this is the customer endpoint. DCE. Where is my... Here we go. Okay, so the DSU is the one who convert the T frame into a frame that the LAN interpret and vice versa. It also connect T carrier's LANs with the terminating equipment. Finally, so it connect with what? T carrier with the terminating equipment, with the DTE. The DTE that usually is a router that belongs to the customer. Finally, a DSU usually incorporate a multiplexer. The multiplexer that it's we talked about it. It multiplex. We just talked about it before here. Here we go. See, so this is a multiplexer here that multiplex all the signals that are coming together in one wave, and after we put it on the carrier wave to be transported, so it will be reshaped, and after we subtract this wave, we're gonna have the other waves and demultiplex again. We're gonna separate all the different signals coming to each destination, right? So we're gonna multiplex and demultiplex. We talked about multiplexing and demultiplexing in the last module, if you remember. All right. Here is a little illustration about the thing. So we have a router with internal CSU, DSU, and multiplexer. That's interesting. You see now when we are using this network card, so everything is in here, right? Everything is on that one router, and that one router, so things going from the router to inside them, they belong to the company. Things going from the router to outside, they belong to the carrier or to the provider. Well, sometimes also we can negotiate those things. Who is the responsibility of who Well, they can take the wall router here as a responsibility from outside if you pay the price for it or whatever. And we're going to talk about it. It's called the demarcation zone. It's something here, right? Demarcation zone. It's just this smart jack here, for example. This is a demarcation zone for it. Okay, so you see data switches, computers, and we have telephone switch. There you go. Here we can have splitter, for example, for all these phones. We can carry voice and data in the same. And after we have a router. So this is a DT-DC. This one here is DT-DC. Okay. This one is doing both because everything is just network card now. All those devices that we saw, router, the modem, the CSU, DSU, and those stuff, they are all merged to those edge networks. So those edge networks, the limit, the extremity for the customer, and they can handle everything. So DC, DTE, data communication equipment, terminate the connection from the carrier. DTE, terminate the communication from the carrier. CSU, DSU, so this is the DCE here, and providing the clocking, because we need a frequency for the carrier, so we need to negotiate the clocking first. And you're gonna do it. This one on the on block 2 when you will configure your routers on packet tracer on the CCNA module. You will have a better idea about this clocking here. So data terminal equipment DTE. You see all working together in the same router now, something like this. Terms CPE, client permise equipment. Client permise equipment. It's a router plus CSU DSU. So you see now we put it everything together here. But before it was separated, we have a router, we have a CSU, DSU. Now we put them all together, or even if they were separated, all this connection or all these things connected together, we call them CPE, client permise equipment. It's a router plus CSU, DSU. So it's a router who have that one connection. You have the one port, right? Not a regular one. Router that have just a RG45 and can link or route informations between LANs. A local loop, new term. What is a local loop? The copper or fiber cable that connect the CPE, so the CPE is all this, right? At the subscriber. So the subscriber is this one. This is our provider here, and they have their own CO network, CO switch here. And this is a local loop. You see that line that connects the client to the provider? This is what we call a local loop. It have a name. It's called local loop. So CPE here, we have a router plus the CSU DSU. The router plus CSU DSU here. We call them client permise equipment. And the client permise equipment is connected to the office or central office here. This is what we call a CO, central office switch. So a local service provider facility or building where local cable link to long haul fiber optic communication lines through a system or switches and other equipment. So that give us access to something that is called a toll network. This is a toll network. The network that belong to the provider. See all the networks that I was designing before. So this is a toll network. This is a CO. This is CP, client permise equipment. This is a local loop. And this is a central office. This is a toll network. This is a toll network, right? So DTE is that last router here, but now it's integrated in one that we call DTE DCE router. And the DCE have CSU, DSU. CSU terminate and correct errors and terminate the communication. DSU handle the reshaping of the frames, some passing from one technology to another technology here. So it's the job of the DSU. We have the clock also, that's handled by the CSU here. And all this here, we call it client premise equipment, CPE. Okay. And that CPE is connected to a central office through a carrier with a local loop. That connection, we call it local loop, right? Of course, here we have a node somewhere that it's negotiated between the client and the provider, that we call it demarcation zone. Demarcation zone. The demarcation zone is usually that junk box somewhere in the building where we connect things. It can have the router or not, depending on the negotiation, or just that smart jack where we put the local loop and after it goes to the router. Usually this is the standard, right? And demarcation zone, it's the point who separate responsibilities. For example, if there is a problem from a demarcation zone to the central office, if there is a problem, it's the problem of the central office to fix it. If there is a problem from that demarcation zone to inside, this is the problem of the company, and the company should fix it, right? So they separate their own responsibilities by a point. Usually it's just that smart jack or junk box at the end of the building where you're going to have that local loop connected, right? But it can be negotiated, so they can take even the DTE, DCE in their responsibility sometimes, right? So you can negotiate that. So the demarcation zone is that point where the responsibility split. It's your responsibility. If something happened from here to inside, is the responsibility of the customer. If something happened from that demarcation zone to outside, is the responsibility of the provider. And this central office give you access to a toll network. So what is the toll network? Is the network of the provider. All right. So we saw client premise equipment, a router plus CSU, DSU. CSU, DSU is what we call a DCE, right? A router usually is the limit of the DTE, data terminal equipment. Local loop, connect the CPE to the CO. What is a CO? Is a central office. The central office is that first switch here. Why we are calling this kind of router switches? Because they are using protocols at layer 2, right? Well, they are much more advanced, using other kind of routing protocols, like for example MPLS that we talk about or whatever. But this one is just a label, packet switching label. This is what we call it. That kind of routing, call it packet switching label. So we take, for example, a router here, and when he have any own destination, he will not do the same thing as the routing protocols that they work in the layer 3, saying that having their own EP table or routing table and measuring distance from this one and this one and this one and find the best way or whatever. No. Those MPLS, they go directly to the final one. They have to pop up. This is the way to go to Japan, for example, or something, right? So they go directly to that router and they will calculate based on that what is the best way between this one and this one, right? But they already have the final destination here. So they don't measure those things in between or whatever, like for example EGRP do, or and they will just, after all the routers in between, they will not measure anything. It's already measured by this thing here, right? Because using other kind of protocols in the ESP, so this router measure things. He know that the best way is to send to this one. He sent to this one, but this one he already have his own math, right? So maybe he gonna change things here or whatever. But MPLS is just those guys here in the middle. They will not see what is inside. They don't care. All they know is it should come from here. It should pop up here. So the packet enters somewhere, go out somewhere. By what? By just this MPLS header, right? So those will save time. They will not calculate anymore. They will do nothing. This guy here already calculated everything and dealt everything with the last one, with the destination. So those depend on that MPLS header. They will just switch the packet, right? The same kind of MAC address is switching, right? So this is what we call them switch, but they are routers, so they are switching packets, and this is what we call a circuit enabled circuit. Something enter here should enable a circuit go pop up to the other side directly through that toll network. So CU, a local service provider facility or building where local cables link to long-haul fiber optic communication line through a system or switch and other equipment. And this is my demarcation zone. So you see here in this illustration, so there's a box here, that smart jack or junk box that you have on the building at the end, where the local loop connect, and it separates the responsibilities. It separates all the responsibilities here. A toll network. So this is a toll network. So you see, this is a building. This is a local loop connected to the central office. And after this central office give access to the network of the provider, or one service provider, is what we call a toll network. And those are just the multi-layer switches. They do routing, they do whatever things, but they usually switch packets. Depend on the protocol that they are working on. All right. Demarcation zone, a point established in a building or complex to separate customer equipment from service provider equipment. Physically, the demarcation point is the cabling junction box on that building located on the customer premise on the CPE that connect the CPE wiring to the local loop. This is the standard, but I told you something that you can negotiate and can give them more equipment. Like, for example, I know that in Herzing, it's included. When we have a big problem with the edge router of the school, it's the provider who's gonna come and fix it. It's not us, right? So you see, that can be different and negotiated. But this is the purpose of this demarcation zone, is to split these responsibilities and to know who have to fix what. PSTN, public switched telephone network, the old way of the analog telephone, right? Originally, the PSTN carried only analog traffic, all of it. Its line where copper wire and the switching was handled manually. God, so you see which era we're talking about. You see these old movies, black and white, and someone is calling on the phone, and he gonna call a lady, and this lady gonna take cables, right? And she will tell him, okay, sir, I will pass you the number in 2 minutes. Please hold on. And she will take the cables and plug them somewhere, right? So this is those switch were handled manually. Now, of course, they are not the same anymore. They are handled by computers. We exactly do the same things, right? We do the same way, but much more advanced. And those ladies find themselves without any job anymore. So they were fired because of computer replaced them. Right now, we are doing it fast, really fast, and just computers and machines that they are doing the same switching things. So today's switching is computer controlled, and nearly all of the PSTN use a digital transmission now. It's not anymore analog. With the DL app connection, a user connect her computer or his computer via a modem on a distant network, and stay connected for a finite period of time. So we are using just the phone lines. We get access to the ESP through the phone connection. PSTN, now it's an ESDN, of course, right? But now is the reverse. Even the phones now integrated the internet. We have this VoIP, right? But before we used the phone to carry. Well, it's the same lines, right? If we are not using fiber optic and new technology, I mean, the old ones still the same lines. T carrier. So the T carrier or E carrier in Europe, right? In Asia, I don't have any idea. I know that Japan have their own standards. They took the best thing of T and the best thing of E, and they merged them to something new in Japan. But in other parts of Asia, I don't know about it, right? So multiplexing enable a single T1 circuit to carry 24 channels, each cable of 64 kilobit per second. Through those, a T1 has a maximum capacity of 24 times 64 kilobit per second, or 1.6 megabit per second. We're talking about T1, right? We have Tel T4, faster and more channels in there. Frame Relay was originally designed as a fast packet switching network over ESDN. This is deprecated. So we're talking here about an access and a toll network that provide a private connection to company's office and headquarters, right? So it's not exactly the same as internet, separated from the internet. Well, it's connected to the internet, but can give links of for many offices of a company in private network, leased ones. DSL, digital subscriber line. So DSL operate over PSTN and compete directly with the T1 and broadband cable services. With the DSL, the distance between the customer and the central office affect the actual throughput. This is one of the disadvantage of DSL. So the more the central office is far, that can affect, because this one is using the same line that we use on the Ethernet, right? This is the trick here. We're using the same lines that we are using in a LAN, local area network. So the more it's far, the more it have an impact on the throughput, the speed, and of course also it's very weak, exposed to interference, same as the LAN. So it's not as strong as using the T1 or the broadband cable, the copper one, different one. This one is when they build it in some area, neighborhoods and cities, so they distribute it over Ethernet cables to get outside, right? Well, it had advantage of speed if it was close and there was no interference, but we had something here that make the DSL special. The asynchronous ADSL, right? So in the DSL, we can play with the upstream and downstream speed. So what they did, asynchronous, they pushed all the throughput to the downstream, right? Because usually when we connect, when we get access to things, we're not really uploading, we're not sending a lot, right? We are more getting a lot, right? So they can balance all that speed to go to the downstream and let a little bit to the upstream, and we call it asynchronous. So asynchronous digital subscriber line, right? So you have to subscribe your own digital line through that almost same kind of LAN technology that you are using now outside to get access to the ESDN over PSTN. Broadband cables. Broadband cables is based on the coaxial cable wiring using the TV signal, right? So this technology was implemented in many neighborhoods, right? They started doing it for TV first. So they distributed TV over cables instead of satellites, right, to homes. And after they said, okay, we can use that big networks we already have for the internet also, right? This is already carrying data. What is having access to the TV through a cable? It's the same thing. We're transporting data, right? So they said, well, we can use it for all the things, for internet, for whatever. This is what we call it the broadband cables. Broadband over power line. This was a test, but it didn't work because of the interference. They said, okay, we have also electrical power infrastructure lines everywhere in the world, right? And everything is connected to homes. We already distribute electricity to people through a big, well constructed infrastructure. Why we will not distribute data over these lines? And they tried and it worked, but a lot of interference and it wasn't really successful. ATM, asynchronous transfer mode, like Ethernet, ATM specific data link layer framing technique, right? So also we had asynchronous transfer mode. It's for the toll network, right? The same thing like a frame relay here. So for a toll network that use this technology, it used like the Ethernet, like the same as the Ethernet. So we took the technology that we have in LAN, we tried to make it on some small toll networks, not really big ones. Fiber cable works well with power lines. Because of its light, and light is not anymore exposed to interference, Davinder, right? But it's not this technology that we're talking about. Broadband over light is just sending a signal with electrical signal with all this electrical interference, right? SONET synchronous optical network. So this is where everything merged together on a SONET multiplexer. Or we can have a T1 multiplexer, DSL modem, a router connected to serial directly, telephone switch. And this thing remind you something here. So this one is building more and more bigger networks in the city using this SONET multiplexer because it's adaptable to everything, can merge them all together. And incoming ring 1, incoming ring 2, outgoing ring 1, outgoing ring 2, where this goes. So it's compatible also with the fiber optic FDDI on the one, right? Incoming ring 1, ring 2, this is FDDI, 2 rings. Remember the FDDI, two rings, right? So we have those first ring and second ring and outgoing ring 1 and ring 2. So those SONET multiplexer that can multiplex all kind of signals and working all together. This is what we use. MPLS, multiple protocol level switching, we talk about it. So this MPLS also work with the frame relay communication here if we have, and after transported over MPLS, go to ATM connection, T line, DSL, T3 line, whatever. And this is another ESP toll network here working all in MPLS. Just a switching packets, labeling. I told you it's just a label that we put on top of the frames of the packets. And if this one should go here, so he should find what is the final destination, and they will negotiate what is the best path. Just the two, they will find it, and after this one, we'll label it first. And once he gonna send to this one or send to this one, those guys will not measure, will not do any load or latency or whatever. They will just switch the packet because they know where they go based on that label, right? Wireless one. Well, we have a one wide area network without cables. Of course, we use as in asymmetrical wired broadband or wireless WAN, downstream data transmission is typically faster than upstream transmission. See, here we have downstream also in the WiMAX or whatever. Usually it's always bigger than the upstream, the speed of the upstream. Collectively, the 802.16 standard known as WiMAX, which was envisioned as a wireless alternative to ADSL and T-Carrier and ATM and whatever access we are using the packets here on Frame Relay. So we have a carrier facility, ESP, and you see that we have an antenna. This antenna is distributing to other antenna, and the devices that they are in the neighborhood of this antenna, they are covered. Okay, the same way for the phone, but here it's just for data. This is the technology that we call WiMAX, one of the most famous wireless technology we use for distributing the internet, for example, or even getting access to leased lines for companies or whatever. So this here is replacing these lines. You see the lines that we're talking about here, right? Or even in our sketch here, see the red thing here, right? So this connection here should be wireless. So we connect through antenna now and wirelessly to somewhere to tell the ESP. We can have it even far. When it's really far, we can use antenna to antenna, or sometimes we go through a satellite. GSM initially only provide voice communication, but added data services with the evolution of GPRS. Well, the GPRS is very old. You people, maybe you don't remember that. We didn't have smartphone at the time, right? But we started using data on this really basic phones. For example, to download a melody, right? We didn't have access to Facebook or web pages. We didn't have touch screen at the time, right? So just basic phones, but we were able starting from the we started using multimedia and so on. That because of this GPRS network, and Ansett also called Edge at the time. Now we are not using those anymore, right? We are using LTE and 5G and so on. Satellites are used to transmit live broadcasts of events happening around the world and to deliver digital televisions and radio signal, voice and video signals, and cellular and paging signals. Geosynchronous Earth orbit means that the satellite orbit the Earth at the same rate that the Earth. How things work. Easy busy. So if we take, for example, somewhere where we have a gap and we should pass through a satellite on the network. As for example, Earth here, right? And we have this WiMAX and we have whatever, the phone, the LTE, whatever. So we have those antenna here communicating one to other one relays, okay? To the ESP, whatever. But sometimes we have gaps, right? So we need to go to the other side of the planet. And in this case, we use satellite that they are orbiting Earth. Now, what we call them what is the term for that? Yeah, geosynchronous. Okay, so those geosynchronous, they are in the orbit and they are turning around the planet Earth exactly with the same speed. Well, a little bit faster. So they will be geostationary to one point here. They will never change their position to Earth. So Earth is rotating from this direction, for example, and this guy is rotating exactly with the rate of speed, not the same, because he had bigger distance to turn around than this point here. So he should go a little faster than this point, but he will be always perpendicular to this point, right? So once you're gonna just see it on the sky, you're gonna see that it's a star or something, okay, reflecting, or you will not even see it. But he will be always stationary here, and there is orbits, special orbits for that. Okay, depend the distance, depend on the weight of the satellite, and so on. So those are geostationary satellites. Now here we're gonna have some parabol communication that we can send the data, and here we're gonna have some reception parabol antenna, right? So we covered all this ocean or whatever distance, instead of having those antenna. This is just around the city. So with cells, this is what we call it, cellular. Each antenna is covering one part and one part. But sometimes when we need a gap, when we have a gap to jump from one place to another one, this is what we use. We use this geostationary antenna, right? So the geosynchronous Earth orbit means that the satellite orbits the Earth at the same rate the Earth turns. So you see the point is turning, but he's orbiting exactly at the same rate. So the position in the Earth will be exactly the same always with the satellite, never change. Okay, guys, if you have any question, please ask your questions. This is about the introduction for the one. Hope it's good introduction, right? At least you have an idea. Be careful with these new terms here, right? We saw many new terms here. DT, DC, what is it? What is a local loop? What is a CPE? What is a CO? What is a toll network? And those stuff. So you should always know what is those things mean, right? You have some questions here, please. So this is your what you have to do today. List for benefits of subnetting. What is the maximum data rate of 811G? One, operate. Focus primarily on which layer of OC module. In one terminology, what is the function of local loop? Describe the demarcation zone. Compare LAN with one. And do a research that we're going to talk about it next Saturday, how to do a lab report. How to do a lab report, please. Just a reminder, you already know, should know. There's many people that they give me wonderful lab reports. Others still struggle. So I'm going to explain, do a research, and I'm going to explain it one last time. I'll give you examples last time. Next Saturday, we'll give you examples with that, right? Here we go. So this is the first assignment today, and the second assignment should be this, I guess. Where is Moodle? This one. Please, I'm waiting for your questions. If you have questions, ask your questions, right? Okay, VPN assignment should be this one. Yeah, all right. So I will give you also this assignment. It's VPN. It's a review about VPN. So last time it's just theoretical questions. I will put it online here in Moodle, so you can also please answer those questions with the questions that they are in chapter 3. So what to do today? I need a report answering those questions here, right? Answering those questions. And also, if you go to Moodle, you're gonna find in 1 second show assignment VPN. So you will find this document here, And list for benefit of subnetting. What is the function of tunneling protocol given PPTP, L2TP, and SSTP protocol? Which one of the three is most secure? What is IKE version 2? What is a pre-shared key? How does PPTP compare to LT2P? You may use pre-shared key with what here? Explain the difference between infrastructure and ad hoc wireless. What is hashing? How public and private keys work? What do VPN provide for security? So this is a review for the VPN questions. Please answer those ones. Why do we have absent option in attendance chat? In attendance chat? What is attendance chat? You mean the attendance of Moodle? They probably didn't program a different view for student and staff. If you want to mark yourself as absent, it's your choice. No, you don't mark yourself absent, you mark yourself present, right? Using this password. Seriously, I don't know how it looked like for the students, but here is what I see as a teacher. Present, 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 and so go on, right? So please take your attendance, guys. Please take your attendance. It's gonna open at 10:30. The second one gonna open at 10:30. If we see it as a switch role to student attendance. Okay, it's already closed. What are you talking about? This, so you should see something like this, but it's not open yet. Anomaly marking is disabled. Well, maybe here set you. Well, just do it. If you have any option of absent or not, put yourself present. It's like logic, right? But I don't know from where it's coming. I can dig after more and see if I can remove it. If this is what you are talking about, right? Is it that, Sheikh, right? Why do we have absent option? Yeah, okay. I didn't know. I didn't even know that you have absent option or not in there. All right, but we'll see if I can remove it after. If you have absent option, put yourself present. Don't put yourself absent, of course. It's really stupid to do that. Okay. Do you have any other question, guys? Any other question? Are we good? Are we good? So, what is next? Next tomorrow morning, I saw that we have one student that have a theory exam retake. So since there is just one, a submission time is 4 p.m. today. 4 p.m. It's just questions, theoretical. You don't have a lab, you don't have nothing. Well, you guys also, please, even tomorrow, right? The people who don't have retake or whatever, and even today, start from today. I need you to install three servers, 2016, and 2 Windows 10 and 1 Windows 7 for the project. So in all, you will have how many machines? 6, right? 2 Windows 10, 1 Windows 7. This is 3 clients and 3 servers, 2016. Get them ready for next Saturday. Get them ready for next Saturday. I don't care. You do it today, you do it tomorrow. You have time, you have plenty time. So I need you to install. By the way, delete all your old machines. Delete all your old machines, guys, right? Make your hard drive empty, have more space. Delete all, not all the virtual machine in the computer. Don't touch the